Okay, section 5.7 continued here with compound inequalities. To solve a compound linear inequality, we're actually doing two separate problems simultaneously. So we're going to see the problem as having three parts. We have a left part, a middle part, and a right part. And then we're going to simplify each of the three parts if it's necessary. We're going to remove all the constants from the middle, okay? From the middle is where we're doing it, all these things. And then whatever we do to the middle, we do both to the left and to their right. And then we remove the numeric coefficient of the variable term. Again, that's in the middle. And then on the left and the right, we multiply by that reciprocal as well. It's three parts that we're dealing with. That's what you always have to remember. So in our example 45a here, we are going to be looking in the middle. So we see that the thing that's being done to the x is a -1. So we're going to add its opposite, a +1. So there's part 1 here, and then over here there's another part, and over here there's another part. So I'm going to add 1 to both the left part and add 1 to the right part. And so what I have is 2 plus 1, which is equal to 3. Inequality symbol drops down into it, and now in the middle I just have my x, and then a less than 5 plus 1, which is a 6. And now I have my solution. There's my compound linear inequality. So I'm going to go locate my left endpoint, the 3, and I'm going to put a left bracket on it because it is included. Then I'm going to go locate my right endpoint, +6, and I'm going to put a right parenthesis on it because it is not included, and then draw the line between. Interval notation says 3 is my left, it is included, so a bracket, up to 6, which is my right, parenthesis, which is not included. And that's how we would solve that. Now, the old-fashioned way, the very basic way of solving these is to go back and say that this inequality says that x minus 1 is greater than or equal to 2, right? Reading from the middle to the left. And then solve this, and so what we do is +1 and then +1, and that says that x is greater than or equal to 3. And you see what we did is we solved this part right here. That's one of our parts. And then we go and we say, and at the same time, right, that x minus 1 is less than 5. And we solve that part. So we add 1 and we add 1, and then we say x is, drop down the inequality, less than 6. And you see that that was this solution here. This is reading this from the middle over to the right. And then the thing that we have to remember is that this is the intersection. This is the and of these things. And the problem is that if you have these separated out by these two different parts, then you have to put them back together. And that's where it becomes necessary to know that we put this one up here like this, and this one down here like this, and then the overlap, which we see right here, is the solution set that we already knew right there if we had done it this much quicker, easier way of seeing the two parts solved simultaneously. Let's go practice that now with a little bit more complicated problem, one that has fractions in it, the one that we're still absolutely capable of solving. So first off, I'm going to change this into an improper fraction, 4 times 2 plus 1, which is 9/4. And now I'm going to see that my least common denominator is 4. So I'm going to multiply every single term in this entire inequality by 4, even the ones that don't contain variables. And then I'm going to multiply and cancel where I can. So 4 times 2 is 8. Less than or equal to, the 4's cancel, 1 times 3 times x is 3x, minus 1 times 4, because there's no canceling, less than, and then the 4's cancel, 1 times 9 is 9. And now I have a nice inequality with no fractions in it again, and I'll be able to proceed on with my process of working from the middle to do each the left and the right problems, and I'll continue that in our next video. You might want to see if you can finish this on your own before you see that next video.